In this problem, we want to find the x and y intercepts of the graphs. So we can find that graphically and algebraically. So graphically, we can go to Desmos. Here. And for the first graph, we see the x-intercepts. Here, negative 2.5. This is the x-intercept, and this is the second x-intercept. So as you see here at the x-intercepts, y is equal to 0. So the x-intercepts are negative 2.5 and 1. The y-intercept is here. It is negative 5. As you see at the y-intercept, x equals 0. Algebraically, if we want to find the x-intercept, we replace y with 0. And then we get x isolated. And to find the y-intercept, we replace x with 0. And for the second equation, so that's the graph of the second equation, we see an x-intercept here, just 2, 0. And there is no y-intercept. The graph doesn't intersect the y-axis. So graphically, I can see that, but let me show you how to do that algebraically because we need to know the two methods. Let's talk about finding the x-intercept here, the x-intercept. We can do that by replacing y with 0. And now we can use the quadratic formula, or we can also factor this. So it will be 2x. And x here, negative 5 can be split as negative plus 5 here and minus 1 here. If we FOIL this, we will see that we will get the original quadratic equation. And now the product of these two guys is 0. So either the first one is 0, so 2x plus 5 is 0. And with this, we get x equals negative 5 over 2. Or we have x minus 1 is equal to 0. So x is 1. So these are the two x-intercepts that we've seen graphically. Negative 5 over 2, that's negative 2.5, as we've seen that in the graph. Now to find the y-intercept, I will replace x with 0 in the equation. So to be 2 times 0 squared plus 3 times 0 minus 5. The answer is negative 5, and we've seen in the graph the y-intercept is negative 5. For the second one here, to find the x-intercept, we replace y with 0. So replacing y with 0, that will be equal to this. And now to remove the square root, I will square both sides. When you square a square root, the square root will be eliminated. So this is 0, this is 2x minus 4. And now we get x isolated, add 4 to both sides, divide by 2. X equals 2, that's the x-intercept, which we found in the graph of the second function. And we know in the second graph that there is no y-intercept, but how can we see that graphically? Again, to find the y-intercept, we replace x with 0. So y will be equal to 2 times 0 minus 4. So that is square root of negative 4. A negative number, square root of negative 4. We know that negative 2 times negative 2 is 4. So square root of negative 4 is not negative 2. And square root of negative 4 is not 4, is not 2 as well. So this number is not a real number. This is a complex number. I mean, in reality, there is no number equals to the square root of negative 4. So that's why this has no real solution. I mean, there is no y-intercept in this case.